Okay, so I think we can start, right? So today we are going to talk about the topic, last topic during lectures before Easter, okay? And then you have 3 labs, as you should already know from the schedule. So today we are going to talk about JavaScript inside the browser and some examples and so on. And then Tuesday, so tomorrow, you have a lab with my colleague about API security. So you finish your APIs and you put particular attention on the security aspects of the APIs, okay? The same thing that we require at the exam from the server side. So if you have doubts or questions and so on, feel free to ask. And I mean, many people have problems with APIs at the exam, so try not to have problems, okay? So try to pay enough attention to this lab. And then there will be 2, I would say, a bit easier labs. One about HTML and CSS, so what we saw last time, just drafting a page in terms of HTML, plus using a little bit of CSS, especially Bootstrap, that is the framework that we are used to, that we use to simplify the development of layouting plus styling, okay? And then last lab next Monday, okay? So instead of this lecture, in this room there will be lab, okay? Your sockets, you should have electrical sockets to use your laptop here as well. And so you will have a lab about today's topic, okay? And then no activity until after Easter, okay? Thursday, April the 9th, there will be lecture, recorded as well as usual, okay? Okay, so no more labs on Thursday, okay? So we canceled the lab on Thursday. Last Thursday there were just 2 persons in the lab, okay? So there are different groups if you want to follow the groups. So these are the 2 updated groups. Okay, so from A to M, more or less, and M to Z. Okay, but again, as long as there is enough room in the room, okay, so you fit in the room, I mean, you can come at any lab. You can even stay for both labs. I mean, for us, it's fine. As long as, we don't have people standing up. Okay. Okay. So I think for the rest of the course, again, we will have only two labs. 2 groups for each lab. Okay. And until the end, we should have 14 labs. Okay. So sometimes, like next week, next week we will only have labs. Okay, or maybe we have 2 labs inside the same week, like this week. Okay, so announcements are finished, and so today we can start talking about the topic of the course. I mean, another one that is JavaScript inside the browser. So from the beginning. Okay, we are recording. Yes. So we learned JavaScript. We learned it's very useful for the server side, okay, but actually that's not the main purpose of JavaScript, right? Server side is just something that can help us to develop something for the server without learning a new language, okay? But actually JavaScript was born to program behaviors on the client side, so inside the browser. And today we are going to discuss all these topics. That's the list of the topics. Well, first, how do you put JavaScript inside browsers? How do you load JavaScript programs? Well, there is a special tag. We already saw it. You remember the script tag that we used when we loaded Bootstrap last lecture, because it has a little bit of JavaScript? Well, today we are going to discuss much more about this. So, the script directly contains code, but we don't like this solution, okay? Because we want to keep things separate. As we did for CSS, we want to have the CSS rules in a separate file. We want to have the JavaScript program, JavaScript instruction in a separate file, okay? think again when the HTML was born and then JavaScript was added and so on, nobody paid too much attention to these aspects. Okay, so JavaScript was not so powerful, a few instructions and so on, so it seemed, let's say, good idea to include the code inside the HTML document. Okay, nowadays it's no more a good idea. So that's the way in which we will include JavaScript manually inside an HTML document, and that's the topic for lab number 6, the one just before Easter. So script src, which is an attribute, remember, with the name of the resource that contains the JavaScript instructions. Okay, so the program. Pretty easy, right? Where do we put it? Where do we put the script? Well, there are two options, either inside the head section or inside the body section. Okay? So head is very clean conceptually, but it's very inefficient, unfortunately. Because head, okay, is devoted to metadata, and indeed the program is not about the content of the page, so that would be the place. But unfortunately, the script, when you put it in the head, executes when the documents, when the browser parses the content, it immediately stops, loads the program, executes the program, and then goes on. Okay, so it's quite inconvenient because at that point the browser didn't read the whole page yet. Okay, so it has no DOM structure. You remember the DOM, that document object model, so the tree that contains all the text of the page and so on. Yes, there is a.
We actually use this feature to, like, having a setup phase for the web page. So
yeah, you could put things for setting up the page, but you don't have the page yet. Okay. So that's a big problem. Typically, inside this JavaScript program, you want to manipulate something inside the page, but the page is not loaded yet. Okay, so that's why we typically don't put it here, at least in this form, because in a minute we will see how to modify this. And so what we did actually with Bootstrap last week was to put a script at the very end of the document, okay? Because in this way the browser already parsed all the document, and at least you already have the document object model loaded, so the tree with all the text loaded in the memory, okay? Okay, neither of the solution really satisfy us, because indeed if you put in the header, you have to fetch the script, execute the script while waiting, and then resume parsing the HTML. If you put it at the end, okay, it's a bit better, okay? But again, I mean, we are not fetching the script until we arrive at the end of the document. So actually, people developing JavaScript programs inside the browsers and developing HTML and so on realized that there was this problem. And so they came up with two ideas, so two new attributes for the script tag. One is this async that just says, well, fetch the script in parallel with the document parsing, okay? It sort of improves the performance, but actually we don't really know when the script will be executed, because it will be executed as soon as it has been loaded. Okay, so it's very generic, not really good. And so actually the preferred solution nowadays, and what we suggest you to do, is to use the defer tag for script that basically it fetches the content in parallel to the parsing of the document, but it waits that the document has been fully loaded to execute the script. Okay, so we don't lose time in the beginning phase. So we are in a situation like this. The browser starts parsing the HTML, so all the content of the HTML. And then at a certain point, it encounters this instruction script defer with the name of a resource to load. and starts loading the resource. Remember, from a server, so it takes a little bit of time because it must download the resource from the server. Okay, especially if the program is big, the JavaScript program is big and so on. Okay, and then it will execute the script only when it finishes parsing the HTML. So everything is correctly set up in the memory of the browser. Okay, so especially the DOM3, that is what we care about in particular. Both these solutions needs to be put inside the head section of the document. So we are back to the head section. Okay. Okay, and then of course you might want to load your program. That's fine, but you might want to load libraries, packages, and so on. Okay, in this case we call them libraries. They are just JavaScript code. Okay. So, just text files that contains JavaScript code. And we are again at the same point as we are with the packages, with package managers and so on. We are loading a resource from outside the place that we actually control, so our web server. And so the problem is, are we importing the resource that we are expecting? So, like, for instance, this is very simple example that you will actually use in the lab as well. So think about Day.js, very simple library, right? But it's JavaScript code. We import it in our page together with our JavaScript code. Okay, we can import more than one file, and later I will tell you. But this code is executed as part of our web application. Okay. So we must be sure that it doesn't contain any malicious instructions, malicious behaviors, and so on. Okay? And so how do we make sure that it doesn't contain any malicious code, malicious behavior, and so on? Well, checking the code is one issue, and we already talked about this. I mean, somebody has to check the code. Okay? There's no other solution. But once we know that a certain version of the library is okay for us, so it doesn't contain anything that is a risk for us, well, we need to tell the browser that it should load the resource and execute the resource. It must load it. But it should execute the JavaScript code only if the integrity hash matches. Okay? We already saw the example with Bootstrap. The CSS has the same problem. Okay, JavaScript is even more dangerous because JavaScript is actually code. While CSS are set of rules, with set of rules, we cannot really give instructions, but we can, for instance, hide things or overwrite things and so on. So it's kind of dangerous as well. Okay, so just make sure you compute the hash in a secure way, okay, as usual. Of course, there are web services, there are websites around that tells you which should be the integrity value to put here in the attribute, okay, as the value of the attribute. But, do you trust the website that is computing that value? Maybe not, okay? So you should actually compute it locally, or maybe in a big organization, somebody should have already computed this value for you, okay, on the version that they are sure it's okay for them, okay? Good. So don't forget to put this integrity attribute and the cross-origin anonymous, which forces the check for, historical reason. We need to have this attribute, okay? Otherwise, the integrity is not checked. So, just remember this fact because it's really important, especially here in this course of study, cybersecurity. Okay, and then we have a program to execute, right? So, where does the program run? Well, actually, it runs inside the browser. The browser has a JavaScript interpreter, as Node has a JavaScript interpreter, same way. But it runs in a so-called sandbox. It's sort of box which is isolated from the rest of the system. So, for instance, programs running inside the browser cannot do actions that instead can be done, for instance, in Node, etc. Okay, because they are programs downloaded from outside. Okay, and especially in the old days where you couldn't check or you didn't pay too much attention to security aspects and so on, you didn't want that random program downloaded from anywhere. Okay. Could perform sensitive actions on your computer. I mean, actions that could lead to problems in terms of leaking information, doing unwanted actions, accessing local files and stuff like that. Okay. Even today, you navigate on a new website. Okay, google.com, facebook.com, whatever you want, polito.com, any website. It's full of JavaScript. They are full of JavaScript, but of course you cannot check the code by yourself before interacting with your website. And you are almost an engineer, but I mean normal people cannot do these checks, right? So the code has to be run in a sort of secure environment, but secure in terms of it cannot access some resources which are critical in terms of security. Okay, local files, local information, talk with other programs in the same browser, see what other websites are open in the browser, and so on. Okay, so these programs are run in a so-called sandbox. Okay, but they have an execution environment like we saw with Node. Okay, so there are global objects and there are other elements that are useful for the program. Okay. For instance, it's JavaScript, so it has access to the standard library. There is the array object, the object, all the functionalities of these types of objects, the date object, I mean the standard date, not the JS that has to be loaded separately, and so on. And then we have something more specific of the environment where we are running. So inside the browser, there are two special objects. One is this BOM, browser object, and the other is the DOM, the document objects. Okay? The DOM, we already saw it, it's a representation, a form of a tree of all the HTML tags inside the page. And the browser objects are service objects, okay, that allows you to interact a little bit with the browser, the program, okay? Like accessing the history, accessing properties of the screen, navigate to a different page and stuff like that. Of course, keeping in mind that not all actions should be allowed or should be possible for a JavaScript program, okay? Or maybe they are possible, but the browser first asks the user and so on, okay? Good, so there is a global context, a so-called window object, okay, that contains all of them. So we have window.document, window.navigate, windows.location, and so on. And then, of course, the object array and so on, okay? Windows is optional. I mean, it doesn't need to be specified every time in the JavaScript program inside the browser. But it's kind of parent object, okay? Parent not in terms of inheritance, but in terms of that it contains all the other objects as properties, okay? Second thing you need to know, in the browser, we can have multiple script tags, okay? So we can load more than one program at the same time in the same page, okay? And so how do those programs interact? Actually, they access the same global scope, okay? And so in short, we could say, if you want to make something available to another program, you should probably add an attribute to the global scope, okay? To window, to document, to something, okay? So in short, of course, we can keep things separate through modules that work also inside the browser, okay? The ES6 modules, and we can load modules through the script tag, but of course, it's a bit difficult to interact between different programs, because we say one file is one single program in JavaScript, and if we have different files, they are different programs, and the only way that we have to interact between each other is to share some global state. That means using global variables. Okay? Okay. Okay. Now, how does the execution environment works in the browser? Well, it works as we saw with the Node. Okay, so the principle is the same. Okay, most phases of processing and interaction with a web document will generate asynchronous events, and so they are processed as asynchronous events. There are functions to be called, so JavaScript code to be called when the events happen. Okay. How does this work? There is the event loop, and there is a code, a queue with the code, and each time there is a new event, the code, a reference to the function to be called, is put in the queue. Okay, and when JavaScript has some time, some free time, so that means in practice it's not executing other code, it takes the first function from the queue, and it executes the code, and goes on and on until the queue is empty. Okay? Events, I mean, we will talk again about events. There can be a lot of, there are a lot of events that happen inside the browser. Not every event requires to be processed by a function. Okay? There are events that have predefined behavior, so they have a behavior already programmed in the browser. There are events that simply doesn't trigger anything because there are no JavaScript function attached to them. Most of them are like this. Or if you attached a program, a JavaScript program, means a function to a certain event, it will be put inside the queue and then executed at a certain time. Okay? So the situation is the same as we already saw when we talked about the node. Okay? So actually, two slides are the same. There is the execution environment, okay? There is the memory heap, so the normal memory where objects, arrays, and so on are allocated. There is the call stack, where functions are put because they can call other functions and so on. When they return, the call stack lowers the value until it becomes empty, okay? And when it's empty, the event loop looks for something in the callback queue. If there is something, it takes the first one, puts it on the call stack, and executes the code. Okay? And if it's empty, simply does nothing. Okay? You load the page, you load the Politecnico web page, you don't interact with the page, there are no timers, no asynchronous loading operations and so on. It does nothing. Okay, it shouldn't consume resources. It's just waiting for the next event to happen. Okay, very simple. Okay, this is the example we already saw. Just to recall, remember, this is the call stack, set timeout. This creates an asynchronous event. Okay, and when it expires, it goes in the callback queue. It's put on the call stack and it's executed. Okay. So everything works like this inside the browser. So in short, if we want something to be executed when an event happens, like a click, or you move the mouse, or a resource has finished the loading and so on, we need to attach a callback, JavaScript callback, and write the code to be executed at that time inside the callback. That's why we talked a lot about the callbacks and asynchronous callbacks as well. Okay? Well, there are a set of APIs available inside the browser, but now we are discussing them in more details. The DOM API, the timeout is available in the browser as well. Ajax is, it's the old way of doing asynchronous requests from the browser. We are not going to see them. We will see a more modern way, the fetch API. Okay. okay, this is just a summary, right? So the event loop, how it works. Just remember that a function call or an event handler is never interrupted. So once we get something and we start executing it on the call stack, next event will wait. I mean, the code for the next event will wait in the callback queue until the code currently executing has finished. So if you write event handlers or any code inside the browser, try to finish as soon as possible. If it's not possible because you have to wait for something, it takes time and so on, you may want to make the function asynchronous. So when it finishes, it goes in the callback queue, and it doesn't block the processing of all the other handlers, so functions that handle other events. Okay? Otherwise, you risk blocking the user interface. Okay? The user interacts, and nothing is happening. But things are getting queued inside the callback queue. They just cannot be executed because the call stack is busy. Okay? Okay, so avoid blocking code. Okay? But this would be normal practice, and we will follow this rule strictly inside our application. It's not so difficult also because today's browsers are very fast, computers are very fast, and so on. So if we need to write a little bit of code, we can write it, but just don't write blocking code. I mean, we need to wait for a resource to be loaded. It cannot be a code that stays on the call stack and doesn't return. It must return, and if it needs to wait for something, it just set up an asynchronous callback. It returns a promise, for instance. We saw the promises, they are available inside the browser. Just return a promise, and then when it's processed, it will be scheduled at a certain point through the callback queue to be executed. Okay. So let's have a look at two important objects inside the browser, because, again, next week in the lab, you will have to use them. Browser object model. So there is this window object that represents a window that contains the DOM document, but also it gives you access to other objects, okay, that allows you to interact with the browser itself. Okay? Okay. So, for instance, it gives you access to the document, that is the root of the DOM, window.document. But actually, window can be omitted in the JavaScript code that runs in the browser. Okay? We are going to see an example in a minute. So with the real browser. Window, it has a lot of, it has some properties. We are going to see these three. Okay? Console. Why? Because you have console log, right? So you can print in the console. It should be window.console.log. Or window.document, window.history, okay, we're not going to use the history today, and not in the next days as well, we will use it indirectly. Or window location, okay, for instance, the current URL and so on. You can even set it, okay, not just read on. Local storage, session storage, but unfortunately we will not talk about this in this course, okay? So, just to see something more practical, right? So let's open any website. I don't really care. Okay, console. Ooh, so much stuff. Okay, let's clean up. Okay, window. Okay, window. Window is available, right? Window.console.log. Hello. Okay, make it bigger. Okay, so this is the JavaScript console of the browser. Every browser has the possibility to run a little bit of JavaScript code through the JavaScript console. This is, again, it's not a special browser, it's the standard browser, just on Linux, but you have it on Windows, Mac, whatever. Okay, in Chrome, in Firefox, in Safari. I'm not so familiar with Safari, but there should be one. Okay. And so, just for practicing, of course, you cannot really use it for developing or programming. Okay, we will program we will develop code in Visual Studio Code as usual. But you can practice with these objects, okay, and test them, okay. Window document, window document, okay. Actually, that's the HTML document. There's a lot of properties that we're going to see in a minute, okay. Note that you can also write console log, okay. Hello. Why? Because I told you, window is sort of implicit. Everything is under window, okay? So you can be omitted in your code, just for simplicity, okay? Good. And so let's have a look at the DOM, because we need to use the DOM to manipulate the content of the page, to create our application, okay? Suggested reading, okay, some links. They should be good links in the sense that I tested them a few days ago before publishing the slides, so they should not be broken. They should still have the content, okay? Sometimes things change over time and links breaks down. Okay, so the DOM is the browser's internal representation of a web page, which is obtained through parsing HTML, okay? So you remember last time we wrote HTML, body, table, tr, table row, and so on. The browser takes this text document, it parses it. That means it transforms it into a structure in the memory. Okay? So a tree structure in this case, and the browser expose an API. Browsers expose an API that you can use to interact with the DOM. And basically, this means that you can, at runtime, using code, modify the appearance and the content of your page. That is actually the basic operation we are going to do to develop a single page application. We load initial HTML, that will load initial JavaScript code, and then the JavaScript code will take care of updating the view, everything that is shown to the user through the life of our web application. It's a single page application, means that we are not going to reload anything from the server. We are doing requests towards the server through the API, but just to get data, not to get new HTML, okay? So HTML, CSS and so on, everything needed to display things or to interact with the user, with the events and so on, will be managed through JavaScript code, okay? So JavaScript code needs to be able to access the content, modify the content, change the content, create new content, and so on. And actually this nowadays is possible, and it's possible through this DOM API that is exposed by all modern browsers. And with modern, I mean last 20 years probably, or something like this, so something really widespread, okay? So unless you really have an old system, really old system, it's probably not, you shouldn't even try to connect to the internet. I mean, these things work, okay? And so now we are going to see all these aspects, okay? Including the last one, add or remove event listeners, that basically functions, JavaScript functions, to be attached to certain events that might happen inside the page, inside the browser, okay? Okay, there are different types of nodes, okay, there is a bit of hierarchy, I mean, to keep things sorted, let's say, in the browser. We are interested basically here in the element, okay, and in the text as well, because between texts, which are basically represented by the element, there can be text, right? There's text shown to the user. Comments, okay, that's interesting, okay? And of course, element can be more specific, can have a certain type, in the sense it can be a certain tag, which in turn has certain attributes and so on. Okay, so I would, leave these slides to you as a reference to be checked if needed, but we try to grasp the main concepts here, okay, and understand how things work. and then the details, again, well, actually, the details, if you really want something specific, you should look into the documentation. For instance, the Mozilla Developer Network, that's fine. Here you will find a starting point, like functions that are typically used, or it's, they are the best ones to perform some actions, like creating new nodes, adding nodes, removing nodes, changing properties, and so on. Okay? So you have like a starting point. The functions that interact with the DOM can both return a single node, okay, so like a reference to a specific tag, or a list of nodes, okay? Like you ask for all the rows in the table, okay? It's a list of tags, tr, 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 and so on, okay? So lists are sort of arrays, okay? For the purpose of JavaScript, in the sense that they have most of the methods that we already saw for JavaScript arrays. So they have the length properties. You can use for each, entries, keys, items, and so on. For off to iterate over the nodes, and so on. Okay. So you already know how to interact with arrays in JavaScript. You basically know how to interact with the nodes that represent single tags in the DOM. Okay? And so we need to understand how to get references to these nodes or list of nodes, and then how to manipulate them. So first of all, to get a reference to an element in the DOM, we need to find it. And to find it, we need to specify which is the element in which we are interested. Okay? Of course, we can always start from the root and then navigate the tree. But of course, it's not so efficient, right? It's so boring. You change something in the tree. You need to change the way in which you interact with the tree. Like you add a child at a certain point, and so you need to change the function and so on. So it's better if we have some ways to get direct references to some places inside our document. Okay? And these are basically the 5 methods that are very useful for this purpose. First one is the most famous one. Get element by ID. Returns a single node that is the one that has an attribute ID equal to a certain value that we pass as a parameter. Okay? That's the easiest one. So there is a collaboration between who writes the JavaScript program and who writes the HTML code. In the HTML code, you have a tag and you mark it with an ID equal to something. And this something, you decide it yourself. As long as it's unique in the document, it's fine. And then in the JavaScript, you want to have a reference to that node, so to that tag inside the DOM. You just run get element by ID, and it gives you the reference. Very easy, right? Or you can, of course, have a more complex situation. You might want to get lists and so on. You can get tags, for instance, by tag name. And there can be more than one, so see the S, the plural, and it returns a name list, okay? By class name, because class is so useful, so used nowadays because of the CSS, and it also represents, what do you say, a class of elements, so a type of element inside your page, and you might want to get a reference to all of them, so a list to all of them. There is a specific method just for class. Okay? Or you remember that we talked about selectors in CSS. You can even identify what you want through CSS selectors. Okay? So query selector just returns the first node that matches, or selector all that returns all the nodes that matches the CSS selector. Okay? So a selector, what is a selector? You remember it's the name of the tag, that is simplest selector. or dot something for the class, or hash something for the ID. Or you had a more complex way of identifying elements. We just skimmed through them, okay, very quickly, but you can find one which is a child of another and so on. It's more complex syntax, and you can use here this syntax as well, okay? This is just a string, a CSS string, the selector part. If it works in CSS, it works here as well. Okay, so just see the simplest example. Main, document, get element by ID main. So there should be ID equal to main somewhere inside the HTML document. Otherwise, this simply returns nothing and means undefined, okay, in JavaScript. Okay, okay, node finding methods also work on any element node, okay? Because nodes are elements inside the tree. You get a reference to an element in the tree, you can run the methods again, but they start from that element as the root of the place where they are searching for the new nodes, okay? It's very flexible. It means that when these methods return a node, actually they return the reference to an object that contains all the information about the node, but also a lot of methods that can be used to further navigate inside the tree, okay? Like here, you can rerun, okay? Get elements by tag name, or, well, it doesn't make sense to search for another ID because it means it's not unique, right? But for instance, you search all the paragraphs inside, it's fine, by tag name, and you can run it on main, okay? You don't have it to run on document. Document is the root, okay? So document, you search for a certain node, and then on this node, on the descendants only, you search for the rest, okay? So I think we can copy-paste this example and see how it works, okay? So a very simple document. You see div ID, class, and so on, and then a script, I mean, just to play a little bit, okay? And let's see how it works. I don't think I have it in the, unfortunately, I think maybe I have it, I don't know. Let's open the Visual Studio Code. There's week number 5. Yeah, that's something which is not simple enough. Let's play a little bit. I think we have time. Yes, we can create a new file. Test is already taken, so methods. What was the name? DOM. DOM. A lot of fantasy, right? DOM HTML. Okay. Of course, it doesn't. Okay, we save it. Why it doesn't save it? Okay, it's saved. Oh, let me close everything. So close. Oh, don't save. Okay. Oops. DOM. Okay, so this is just the usual stuff that we can write in HTML, right? So there are just 3 divs, so we can load it, but you cannot see anything, right? So, what's the copy path, right? I guess. Paste. Okay? We see nothing, right? So, why? Because there's nothing to show. But actually, it's there. Div, div, div. There's nothing inside the div, so the document is empty, right? I mean, in terms of what you can see here. But you can run this code, okay? Of course, this code is run, but it didn't do anything. I mean, I'm not sure. Yeah, it didn't print anything on the console, okay? We could have done console log and so on. It's just there for helping us. So document, get element by ID, foo. Okay. What you see here is the return value, okay? Of course, in JavaScript, we assign it to a variable, and then we should use attributes and so on. But the nice feature of the console, JavaScript console inside the browser, is that it sometimes allows you to navigate the object. So it's sort of simple debugger, okay? So you got the reference to this object, and you can navigate inside this object. So you can see all the properties. You see how many properties you have, okay? And you see, what can you see? ID foo, okay? That's a property, that's the attribute, okay? We had the ID foo. And so we actually have the, oops, sorry. I didn't expect it moved. And so you can get easily a reference inside the JavaScript to what you need in the document. Okay? A lot of event handlers and so on. Okay, but this is just to show you how many things are present here. Okay, tag name, div, okay, style, etc. Okay, good. Just to tell you, it's easy to test these things by yourself. Okay, we can select. We can use maybe the third one. Query selector all dot bold means all the elements that have class with at least bold as one of the values inside the class. So it will select 2 divs. Okay, let's try. Copy, paste. Okay, so you see this is a node list. Okay, it's not a node, it's not a single node. So it's an array, sort of array. It has a length, 2. It has all the methods that we cannot really see immediately because all the stories of JavaScript, how it handles inheritance and so on. We didn't talk about this, but I mean, you can write dot length and see the length. You can write the for of, the for each, and so on. And the first one is div bold, the other is div bold color. Okay? And as we did before, you can see all the properties, etc. So, in short, you can play a little bit and also experiment interactively with these methods. Okay? Okay. Once you have a reference to an element inside the tree, you might want to move inside the tree, navigate the tree, right? So, which are the properties and the methods which are useful to do this operation? Well, you have, I think these are all attributes, like parent node, it gives you a reference to the parent in the tree. Next sibling at the same level, or the first child, last child, or the child nodes, which of course is an array, okay? A node list actually. Just in case you want to go down inside the tree, okay? Good. The attributes of the HTML elements, we already saw it, become object properties of the DOM object. We saw it before, right? We had the ID property, right? ID was added because there was an attribute ID inside the node, okay? Inside the tag, and so it went inside the node. And you can access it with the dot notation, but you can also access it with the square brackets notation, okay? Just attributes of a JavaScript object, as we saw first lecture of this course, okay? These are examples, but I mean different examples also for Boolean attributes and so on, but I mean we don't really care. Once you need them, you search for them and you will use them, okay? Attributes can be handled by special methods like this has attribute, get attribute, set attribute, remove attribute, and so on. Matches CSS, if it matches a CSS selector, and so on, okay? So, plenty of methods, again, also to work with attributes. You can create elements from, from scratch. So, we want to add something inside the DOM tree. either we create an element, we need to modify the HTML, or we can do it directly in JavaScript. Just create element, create text node in case you want to have text inside the tag. Okay? So div, create element div class name, div inner text, and that's the resulting code. Okay? Oops. Let's try this code. Okay, code, copy. We are here, right? So paste. Let div class name, div inner text. Okay, fine. So you see the, oops, where's the, you see the div, okay? But where is the div? Especially, where is the inner text? There's nothing shown here, right? Well, actually, you see next slide, it says, if not inserted in the DOM tree, it will not appear in the browser window. So remember that if you create something, you need to insert it at a certain point in the DOM tree. Okay? This exists, but only in the browser's memory. So, document body append child div. So we append it directly under body. Let's try. Paste. Okay? You see that something has appeared here. A bit small, right? A bit too small. Okay? But see the structure. It didn't update the structure. No, yes, it updated it. Sorry. It appended at the end. Okay? So append child appends at the end of the list of children. You see the div. Okay, we didn't type a div, etc. We just created it with JavaScript. That's possible. Actually, that's actually what all single-page applications do all the time. Okay? We will not do it directly. We will use a library later on in the course, React, that does it for us. But basically, that's the principle. Okay? Okay, good. So back to the slides. And as you saw, we appended a child at the end of the list of the children. We can append in different places and so on. Again, a lot of methods. There's no need to memorize them. Just you need to know there are methods to do more or less whatever you want. Okay? Insert before a certain node, replace, append, prepend, before, after, and so on. Okay? Just because, of course, you want to insert it at a certain point in the tree. Okay? Just for flexibility. Of course, one method is enough as long as we have the correct node on which we should call this append child. Okay? Or append a sibling. Like. But, to simplify development, a lot of methods are provided. And then you saw that we created a text node, because inside many texts, we can insert text, right? So that's a text that is shown in the browser, right? So this text, for instance. And we can create the text in an easier way than create a new text node and append this node and so on. Okay? There is a property, actually two properties. One is inner HTML and the other inner text. So in short, this is just an attribute. We assign a value and the browser does the rest for us. So inner HTML, if we assign some value here, it gets parsed by the browser immediately as HTML. So if it's just text, it's just text. Okay, it becomes a text node. If it's HTML code, it is converted into elements in the DOM tree and appended in that place where we use the inner HTML. Okay, so have a look at an example like this. We have a div inner HTML, and we assign a text like this, okay? Div inner HTML equal to quotation mark, strong, and so on. I mean, just strong is just like the bold, okay? Probably not a good example in the sense that, I mean, we want to make these things through CSS, but I mean, to do something which is visible and very quick, sometimes we rely on this, let's say, old-fashioned tags, okay? And so the browser basically creates a structure like this inside the div, parsing the content. If it's HTML, it recognizes it is HTML because you use the less than sign and the greater than sign. So there is a tag and the close tag and so on. So it parses it, it creates a new node, and it puts the text inside. Okay? It's very good in the sense that it's very, how to say, it's very nice to have because it avoids, we avoid writing a lot of JavaScript code. Create the node, and append the child, and so on. But it's also a bit dangerous, okay? Again, here, let's take another div. Which div do we have? Div ID foo, okay? So let div node, okay, div node, document get element by ID. You remember we said what's the ID? Foo, okay, foo, okay, okay. Div node dot inner HTML equal to, I already had a quotation mark. Okay. Just enter, and let's see what happened. You see, div ID foo, now it has something inside, and it has a tag plus some text. So this has been completely managed by the browser. Okay, we didn't do create node, append child, and so on. Nothing. The browser did everything. Okay, very powerful, but also quite dangerous. Why? Because if the content is not coming from a secure source, that means it's not coming, for instance, from our program, but from some external input, wherever, it can contain tags which are dangerous, like the script tag. If there, we write a script tag, and then we write something in JavaScript, it gets parsed, it is a script tag, the browser interprets the script tag, it executes the code, okay? So it becomes dangerous. Or maybe it can contain some CSS code in some elements that goes and overwrites something and tricks us in doing operation we don't want and so on, okay? Tricks the user, okay? In terms of appearance and so on, okay? So I would say this exists, very powerful, but as we will see in the lab, probably the only safe way to use it is this one. I mean, which is not that useful, of course, but use it to set an empty string, right? So to remove everything, okay? So in this case, you see there's nothing left, okay? Otherwise, the rest can be dangerous, because if it contains something that comes from insecure sources, that's a problem, right? And exactly for this reason, and also because sometimes you need to set this text, there is the inner text attribute that does more or less the same, but it doesn't perform the parsing. So it's assumed that everything is text, okay? So, for instance, let's see this example. This is available, right? So we have it in already We have it already published here. So that's an HTML document, very simple. HTML add, empty add, body, div, blah, blah, blah. And then there is ID time, okay? That initially contains hello, but then we want to replace this content with something else, in particular with the time, okay? So we play a little bit with something which is less trivial. Okay, to use the time, we need to import, well, we could use the date object from JavaScript, but, you know, from the beginning I told you it has limitations and so on. So let's try to use this library, so we practice with libraries as well. And so how do we import the library? Well, this is the very old way. Okay, we didn't put it in the header with the defer. Okay, it's at the end of the body. It's fine. It's before the code that needs it. It's fine. And so we import this library. So it means we say to the browser, please load this library. Just check the integrity when you load it and so on. And then it's available in the global object. Okay, that's the only way that we can use to share information between the different scripts inside the page. But it's more or less what we already did in Node, right? So there is a new attribute of the global object that is the JS, and you can use it, okay? And then format, okay, or minus seconds. And let's just try it, test it, right? So copy path. Or you can just search for it in your file system. Okay? You see what happened? There is a time there. And this is the body. Initially, there was hello, but then the browser executed the script, and it changed the content with inner text. Okay? You see the code here, and you can even debug the code. I think, yes, you can even debug the code. I mean, it's a bit difficult to do it. Probably it's not worth learning it, because when you have React and so on, I mean, it's more difficult to debug the code than try to figure out which errors are present with some other tricks, okay? Okay, so you see the time. Okay, almost time for the break, right? Okay. So, in short, we realized that we just implemented, actually, a page, an HTML page, where there is some JavaScript content, so JavaScript program that has been loaded, executed, and it changed a part of our content in the page. So, a small piece of our DOM tree, okay? Automatically, we didn't do anything, right? The browser executed the code and did it for us. Okay? Okay, good. We say, okay, inserting the HTML, there are all these methods which are dangerous. All the methods that are called HTML are dangerous, because if the HTML cannot be trusted, it's a real big problem, okay? But there are also the ones with the text, okay? And so you can put whatever you want in the text, they are safe. You can clone nodes and so on. We will do the events later, okay? So last thing before the break. We can also play with the styles, okay? Styles means CSS in short for us. Okay, so we can change the class attribute of nodes, and so we can apply styles. Okay, just be careful that class is a reserved word in JavaScript. Okay, so unfortunately, okay, we don't have the dot class attribute, but the name of that property or attribute is class name. Okay, and not class. because class is a reserved keyword. Because at a certain point in ES6 and previous versions, they decided to introduce these sort of classes, even though they are not really good for doing object-oriented programming because of the limitation we said in the first lecture. So no private methods, no private properties, and so on. But we need to, let's say, deal with this situation. So there is a class name, but also it's possible to use a class list to add and remove, toggle, and so on classes. Okay, classes means strings to be added to the string contained in the class attribute in HTML. Okay, and this is really important because sometimes you change the appearance of your document just changing the class names. You remember Bootstrap? Bootstrap, last lecture, was based on the fact that you used classes applied to tags to get some behaviors. Okay? Both for the layout and the presentation. Okay? For instance, you remember the call 3, call 4, call 12, and so on, call number of columns and so on. But you can also present things differently. Okay? You remember the primary, secondary, and so on. If you load Bootstrap and play with these values, you will get different appearance. Okay? And you have a way to manage those classes through JavaScript. Okay? So again, they are one of the many methods available on nodes inside the DOM. Okay? Okay, element.style contains all CSS properties. I think we saw it at a certain point. Oh, now I reloaded the stuff. Document.div. No, not get. Get element by ID. What's the ID? Time. The string, sorry. Okay, and it was style at a certain point. You see style, which actually, I mean, there's plenty of attributes, but I mean, all of them are empty, so they have a default value, probably the default value of the browser. Okay, but you want to change something like border and so on, you just change it. Okay, and they get applied to the nodes. So the message in short is we have basically methods to do whatever you want with these nodes inside the DOM tree. Okay, create, remove, append things before, after, and so on, and they even insert new HTML code. Okay. Change the style, etc. And everything is reflected automatically and immediately inside the browser window, as we saw before. Okay? So that's basically the building blocks to create a single page application. So a single page application loads the HTML, loads the code, and then the code takes care of updating the interface depending on user interaction. Okay? And what data has been loaded from the server and so on. Okay? And you just need to practice a little bit. Okay? And there is a lab, the 6th lab next week, just to practice a little bit with these methods. Okay? Okay, so I think we can have a break, like 10 minutes break. And after the break, we will see something a little bit more interesting, I hope less boring. And in the sense that we add event handling. So the user does something, or maybe there is a timer and so on. So things start to change inside the browser window because of user interaction or because something else has happened. Okay? Okay, so if you don't have any question, we have a break, 10 minutes break. Okay, thank you.